Light speed might be evolving, not fixed. What if the number you memorized as the speed of light in vacuum is not a hard cosmic speed limit at all, but only what your own rulers and clocks report from inside a living medium that has been changing since the universe was young? In the energy filament theory, light is not a characterless ray flying through empty nothing. It is a twisted filament with thickness and length, braided like a tiny rope and riding on an invisible energy sea that fills all of space. So if you imagine holding a long rubber cord, twisting it into a spiral and snapping it so the twist runs along its length, a light pulse in this picture is that finite packet with its own inner swirl rather than an endless straight mathematical line. The filament has a birthplace inside matter, because stable particles are not solid beads but loops of the same filament locked into ring currents in the sea. And the way the swirl is knotted inside a particle decides what kind of light it can emit. However the internal swirl is twisted, the emitted filament inherits that twist. Whichever angles that swirl opens like a nozzle, those are the directions the filament is allowed to go. The shape of light is carved by the swirl and the direction of light is chosen by the swirl. Once you have this shape in mind, you can ask how light actually moves. And here sound gives you the cleanest picture. Because when you shout, you do not throw a lump of sound stuff from your mouth into a friend's ear. Air molecules mostly stay where they are, each one shakes in place, passes a shake like this instruction to its neighbors and then calms down. Layer by layer the pattern moves and your friend hears the shout. So in this theory light works the same way with one big change. The medium is not air. It is the energy sea. You can imagine the sea as an elastic three-dimensional mesh. A tiny patch gets kicked into a twisting motion, follows a braided rhythm, then hands that rhythm to the neighboring patches and relaxes. Seen from far away, you say that a beam of light shot across space. But underneath there was only a chain of local relays. That is why light, gravitational waves, particle ring currents, and even cosmic background hisses can all be read as different motion scripts in the same sea. Because some scripts form straight relays mostly in one direction. Some close into loops and show up as particles, and some are short-lived and chaotic. Yet in every case the underlying instruction is the same: perform this movement here, then pass it on. Once you see the filament and the relay, the line between light and matter looks very different. Because as long as the twisted filament stays open, with two ends that keep wanting to be relayed forward, it shows up as light as a traveling disturbance. But if those ends are brought together and the filament is closed into a ring, the same object switches lifestyle and the twist runs around and around inside the loop with no start and no finish. So from outside you call it a particle. In this language energy conservation stops looking mysterious. Because light and particles are not two separate substances. They are the same energy filament in an open or a closed state. You can push on a closed loop, loosen part of its knotting and let a segment peel off as light, or bring the ends of a light filament together and tie them with the right swirl to lock a new particle. So one filament holds two storage modes instead of two kinds of stuff. With that picture in place, you can finally look straight at speed. Because school tells you that the speed of light in vacuum is a universal constant and the ultimate limit in nature. Experiments do keep measuring the same numbers. But the filament picture adds a deeper question. Is this constancy telling you about the true local speed limit of the sea itself, or about how your entire measuring system behaves while sitting inside that sea? The sound analogy becomes more than a metaphor here. Because in air sound crawls at a few hundred meters per second while in steel it races at a few thousand. The same kind of push goes much faster in a tighter, more rigid medium. Extends that instinct to the energy sea and a new intuition appears. Wherever the sea is tighter, its relays run more easily and more quickly. So if in some era the cosmic sea as a whole was pulled tighter than it is today, the true local maximum relay speed for light filaments could have been higher than the value we call c. At that point you have to separate two things that are usually blurred together. The real local maximum relay speed, set by the tension of the sea in that region and free to drift slowly as the universe evolves. And the sea that you actually read off in the lab, which is a ratio. how fast the filament's pattern moves compared to the length of your rulers and the tick rate of your clocks. The catch is that if the sea tightens, it does not only push on light, because your rulers and clocks are built from the same sea and are themselves patterns inside it. The atomic sizes that set your meter are controlled by electron orbits and energy level gaps that depend on the sea's tension. And when the sea tightens, those grid cells quietly resize. While the ticking transitions in your atomic clocks are also internal rhythms of the sea, and when the sea tightens, those beats shift as well. That means that when you measure light with a ruler that stretches and a clock that changes tempo in steps with the medium, you always get the same ratio. You divide the relay speed by the stretched length and the retuned seconds, and the number comes out constant. You give that number the name C. And now the true relay limit written into the sea is free to slide very slowly over cosmic time, while almost every direct experiment remains blind to the drift, simply because your whole measuring apparatus is being retuned by the same hand that is retuning the light. The punchline is that we are unlikely to see a slow evolution of the true local light speed just by timing beams, since you and the beam are being changed together. So if you want to know whether light could once run much faster than today's CU, had to stop staring at lab clocks and instead look for time fingerprints in the sky. The most famous fingerprint is the cosmic microwave background, the faint afterglow of the young universe, which is astonishingly smooth, regions on opposite sides of the sky, which by today's sea should never have exchanged signals, still showing almost the same temperature. That mismatch between how smooth the sky looks and how little time there seems to have been is the horizon problem, and standard cosmology patches it by adding a brief burst of inflation in the very early universe, a rapid swelling of space that allows once connected regions to get yanked far apart later. In the filament picture you can tell a different story, because if the early energy sea was globally tighter, the true relay speed for light and other signals was much higher than today. So there would have been enough physical time for distant regions to exchange energy and smooth out their differences without any extra inflation episodes. And the smoothness of the microwave background then becomes evidence that the sea, long ago, was in a different tension state from now. Once you accept that, it is natural to link it to another claim that this theory makes, namely that particles themselves, as knotted loops in this sea, should respond to its slow tension drift. So their sizes, lifetimes and couplings can shift slightly and systematically as the sea relaxes. In that light, the idea that light speed might evolve and the idea that particle properties may evolve stop being two unrelated speculations and become two phases of the same underlying process, the gradual evolution of the energy sea's tension, showing up on a macro scale in how fast relays can run across the universe and, on a micro scale, in how the tiny clocks and rulers inside atoms adjust their beats and spacings. From this angle, the old picture of a photon as a cold point darting along a fixed straight line at an unchanging speed gives way to a richer one, where light is a shaped, rhythmic filament soaked in a restless sea. The sea's tightness writes its profile, picks its allowed directions, deciding whether it stays open as a beam or closes into a particle, and quietly sets the real local speed limit beneath the constant we call c. And what your instruments report as an unchanging number is really the steady, the ratio between that evolving relay speed and the evolving standards you build from the same medium. Tap follow, share it on.